Assalamu alaikum. Today I am going to explain the definition of homeomorphism. So, right definition of homeomorphism. Let's say X and Y be topological spaces and let f is a continuous function from x to y be a bijection with inverse f inverse y to x is a mapping if f and f inverse both are continuous functions both are continuous functions then we can say f is uh, said to be a homeomorphism if there exists a homeomorphism. Basically, homeomorphism is a continuous function between two spaces. If there exists a homeomorphism between x and y topological spaces, we say that x and y topological spaces, as we know, x and y are homeomorphic. S and y are homeomorphic or topologically equivalent or topologically equivalent denoted by this symbol. So basically, homeomorphism is a definition. Homeomorphism is a function between two topological spaces x and y. How can we say f is homeomorphism between x and y? If f and f inverse both are continuous and bijection between x and y, f is a bijection from x to y and f inverse is the bijection from y to x, then we can say f is the homeomorphism. Means homeomorphism is a function from x to y and the two topological spaces. So, and in other words, if the homeomorphism exists in between two topological spaces x and y, means if there exists a continuous function satisfy these conditions, then we can say that x and y are homeomorphic or topologically equivalent and denoted by this. Now I am going to explain an example of homeomorphism. Two spaces are homeomorphic, a function homeomorphism between two spaces x and y. Let's say two set. X is a set whose elements are a, b, c, and y is also is equal to x, a, b, c. According to this set, we define a topology on X set y, x, a, b, b, c. This is topology because the three axioms of topology satisfy this set, this collection. So phi is also and x also belongs to a, b. If the union of a, b is here, if the intersection of a, b here, and if we take the intersection of this a comma b comma c, so this is here belongs to, if the union intersection of these two sets are a comma b comma c is b here. This is topology, and this topology related with y set. This is a sub collection of y. y belongs to according to definition, and the null set and the whole set also belongs to topology b comma c comma a comma b and b comma c. If the union of b comma c here, if the intersection of b comma c here, and if intersection between in these two sets ab and bc is b here, so we define a map from x to y. F is a map from x to y given by these conditions. If we input in this map, we will get C. Means this is set x and this is set y. If we substitute A in this map, we will get C. If we substitute B in this map, we will get B. If we substitute C, we will get A. So if we substituted A comma B according to this, because we want to satisfy the condition of homeomorphism, if we substituted these input in this function a comma b, we will get b comma c, because the input of a is c and the input of b is equal to b. So the input of the output of a comma b is equal to b comma c, and the input of the output of b comma c, the input of the output of b is equal to b, and the output of c is equal to a, so a comma b. So according to the definition of homeomorphism, we only want to check if the open set, if u is a open set in y, simply I can say if u is the open set in y, second space topological space, and if we apply input in inverse function, then we get output v. If we input open sets in inverse function, means the inverse image, pre-image of this open set, this is open set in this topology, so the inverse image of this open set is a comma b, and a comma b is open in this set, this collection a comma b. If the inverse image of this a comma b, the inverse image of a comma b is equal to b comma c, so b comma c is open in this. So if we check this, the inverse the pre-image of c is equal to, the pre-image of c is equal to a, so a belongs to here, a is open set. The pre-image of b is equal to b, so b belongs to there, b is, and if we check a, the inverse image the pre-image of a is equal to c, so c does not belongs to here, c is not open in this topology x. So if this c does not belongs to the pre-image of a, the pre-image of a, but a is not here, we checked for open sets, so a we will not check for a. If we substitute it, if we check the pre-image of this open set, the pre-image of b comma c is equal to b comma c is equal to a comma b. A comma b is open is here. If we check a comma b, the pre-image of a comma b is equal to b comma c. B comma c belongs to here. If the pre-image of c, so the pre-image of c is equal to a is open here. If we check the pre-image of b, So pre-image of B is equal to B. B is open here. If we check input empty, the open pre-image of empty is equal to empty. And if we check for open space, so if we check open set of the if the pre-image of this, so the image of this is equal to this open is here. So X, we can say that X is homeomorphic to Y, because all the open sets pre-images belongs to this is open, are open. So this is homeomorphic. So X and Y are homeomorphic according to this function. This is the homeomorphism between X and Y.